Welcome back to Physics in Motion. Today we're diving into one of nature's most incredible inventions, the human eye. We'll explore how it works, what can go wrong, and how science helps us see clearly again. Let's start with the amazing structure of our eye. Think of it as nature's own high-tech camera. At the front, we have the cornea, a transparent protective layer that begins focusing light as soon as it enters. Next comes the pupil, that black opening you see in the center. It's like the aperture of a camera, controlling how much light enters. Behind the pupil sits the lens, a remarkable structure that can actually change its shape to fine-tune our focus. Pretty amazing, right? At the back of our eye is the retina, the light-sensitive screen where all the magic happens. This is where light gets converted into electrical signals. And finally, the optic nerve carries these signals directly to our brain, where they're interpreted as the images we see. Now, let's see how a perfectly healthy eye works. When light rays from a distant object enter our eye, they travel in parallel lines. The cornea and lens work together as a team, bending these rays inward, a process called refraction. In a normal eye, these rays converge at exactly the right spot, right on the retina. This creates a sharp, clear image that gets sent to our brain. This is perfect vision, when everything focuses exactly where it should. But what happens when things go wrong? Let's explore myopia, also known as nearsightedness. In myopia, the eyeball is slightly too long, or sometimes the cornea is too curved. Watch what happens to our light rays now. Instead of focusing on the retina, they converge too early, in front of the retina. This means distant objects appear blurry while nearby objects remain clear, hence the name nearsighted. But don't worry, science has a solution. We can correct myopia using a concave lens, also called a diverging lens. Watch carefully. The concave lens spreads out the light rays slightly before they enter the eye. Now the rays focus exactly where they should, right on the retina. The image becomes sharp and clear again. That's the power of understanding physics. We can literally help people see better. Now, let's examine the opposite problem, hypermetropia, or farsightedness. In this condition, the eyeball is too short, or the lens system isn't powerful enough. Look at what happens to our light rays. They're trying to focus, but the retina gets in the way too early. The rays would actually focus behind the retina if they could continue traveling. This makes nearby objects blurry while distant objects remain relatively clear. The solution? We use a convex lens, also called a converging lens. The convex lens gives the light rays extra converging power before they enter the eye. Now watch. The rays focus perfectly on the retina, creating a sharp image once again. Amazing how a simple piece of curved glass can restore perfect vision. Let's quickly recap what we've learned today. A normal eye focuses light exactly on the retina, giving us crystal clear vision. In myopia, the image forms in front of the retina, making distant objects blurry. We correct this with a concave lens. In hypermetropia, the image would form behind the retina, making near objects blurry. We fix this with a convex lens. The human eye truly is a marvel of biological engineering, and understanding its physics helps us solve vision problems that affect millions of people worldwide. Thanks for joining us on Physics in Motion. If you found this helpful, give us a thumbs up and subscribe for more amazing physics content. Until next time, keep exploring the incredible world of science.